remembers from yesterday how we started these. We did 180 divided by 4. In other words, we changed this into a degree. So this is pi, if all we had was pi, we'd know that would be 180. But it's divided by 4, so 180 divided by 4 is 45. So we have a 45 degree angle that we are finding the cosecant of. So I'm going to draw my triangle, and this is the same triangle I have drawn a zillion times.
45.
And I put a 45 right here. And as soon as I put the 45 right there, I know this is a 45, 45, 90, right? And according to what I have memorized, or look at my pink sheet, the sides are 1 and the hypotenuse is root 2. Those are the ratios of the sides in a 45, 45, 90. Now, cosecant. That is not one of the big three. The big three are sine, cosine, tangent. Cosecant is the flip or the reciprocal of what? What is cosecant the reciprocal of? Sine. It's reciprocal of sine. Sine is the reciprocal of the cosecant. Cosine is secant and tangent is cotangent. Those are the reciprocals. I told you yesterday, in each pair, there's only one C, one co in each pair. So the cosecant goes with the sine. The sine is opposite over hypotenuse. So the cosecant will be hypotenuse over opposite. So if I come over here to my picture, hypotenuse is root 2, and it really doesn't matter since they're both 1s, but this is the opposite over here, right? That's the opposite side. So it's root 2 over 1 or root 2. The answer to the problem is just root 2. So we did all that work, and the answer is root 2. Cosine pi over 3. All right, same thing. What do we do first? We got to figure out how many degrees this is. So that's right. So pi is 180 divided by 3. So this is the cosine of 60. 60 is not the answer. I just now know what angle to draw, right? I'm going to draw a 60-degree angle. And as soon as I put that 60 in there, I've got a 60 or 30, 60, 90 triangle, right? So I know the sides. I got to know the sides. I can look at my pink sheet now, but I have to know the sides eventually. Across from the 30 is 1, across from the 60 is root 3, and the hypotenuse is 2. Just like you memorize plays in football or volleyball or music and band, you gotta memorize some things in math. Just memorize it. Now I need cosine. Well, cosine's an easy one. It's up here. So cato, it's right there. So cosine is adjacent over hypotenuse. So looking at the picture, here's the adjacent, right?
1 over 2.
So the answer is 1 over 2. Yep, 1/2, 1 over 2. Everybody in agreement with that? Okay, while I'm thinking about it, I do have some extra practice work for you. So I'm going to go ahead and hand it out. And then we're going to start the next section, which is some calculator work. But since you have some days off math, you might want to do some extra practice. And I can't remember if it all has answers, but a lot of it has answers provided. So that you can
Once you do it so much, but you don't get bored of it. You just feel weak. The only thing that ever gets sore from me is right here. That's it.
Okay, everybody got an extra practice packet? Okay. All right, so now I'm doing part 4, which says evaluate with the calculator. So we just did some evaluating by hand, but every problem we did by hand had to be either a 45, 45, 90 or a 30, 60, 90. The ones we did yesterday and the ones we did today. Those are the only special triangles we have. So when we have an angle like 10 degrees in this next problem, I can't do that without a calculator. I'm going to do it on my calculator. All right? So, first thing I need everyone to do is go to mode, and mode is right next to the second button. See mode, top row, mode. And when you press it, make sure that degrees is highlighted. So if it's not, just click over to it and highlight it. All right, so is everybody checked? So we're in degree mode because the very first problem I'm doing says find the secant of 10 degrees. My calculator needs to be in degree mode if I'm going to find the secant of 10 degrees. Okay? So we are on part 4, page 33. We're finding the secant of 10. Now, look carefully at your screen. Do you have a secant button?
No.
No. You have sine, cosine, and tangent. That's it. So you have to know that the secant is the reciprocal of the cosine. And when I type this into my calculator, that's how I will type it in. 1 divided by cosine. That's what I type on my calculator. You don't need to type the degree symbol. Just type 1 divided by cosine 10. And it says, it doesn't tell you how to round. Let's do the 1,000. So it would be 1.015. To do secant, you literally type 1 divided by cosine. All right, everybody get 1.01? Easy. Now, I'm not going to do B right now because that's a radian measure. And my calculator is set in degrees. So I'm going to skip down to C. So I've done A, now I'm going to do C. Now we all know how to put this in. Do I have a tangent button? Awesome. Press tangent. And then you have to press 28 second angle degrees, 11 second angle minutes, and you should get 0.536. So C should be 0.536. Is that what you got?
Yeah, we skipped B.
We skipped B.
We're doing all the degrees.
We're doing all the degree ones because my calculator is in degree mode. If I did B, I'd have to switch it back to radians and then switch it back to degrees. So I am I'm doing all the degree problems first. All right. So where's the next degree problem?
E.
E. So now I'm doing cotangent 1319.
So it would be 10, 1 divided by...
So yes, you're right. I don't have a cotangent button. So I'll type 1 divided by tangent 1319. Cotangent is the reciprocal of tangent. So 1 divided by tangent, and then 13 second angle degrees, 19 second angle minutes. Did you get 4.225?
Yes.
4.225 is the answer to that one.
Do you put a degrees on the phone?
No, the functions do not have labels. They are ratios. So if you are finding a sign or something, it's just the number.
So you're always putting it over 1 when it's like the opposite divide by
When
1.
it's the reciprocal.
Don't put it in there. So do 1 divided by 2.
Okay. All right, now F. F is another degree problem, right? Do I have a sign button? So I press it. And then 127 second angle degrees. 18 second angle minutes. And then I need that 13 seconds, so 13 alpha plus. Did you get 0.795?
Yep.
So that was F. 0.795.
Now we gotta do I and J.
All right, and then, yep, Jaden says we have to do I now. So cotangent 158.19. How do I do a cotangent?
1 divided by 10.
So 158.19 is going to be 1 divided by tangent 158.19. That's okay. That's okay. They can come out negative. Sometimes they are.
Yeah.
So 1 divided by tangent 158 second angle degrees, 19 second angle minutes. Yep, I got negative 2.515.
Yep.
And then J. Do I have a tangent button?
Yeah.
So I just press it, nothing fancy, I just press it. So
Yeah, yeah.
tangent 300 second angle degrees, 18 second angle minutes. Oh, another negative. Negative 1.711.
7
So that's J. Negative 1.711.
Now do we go to mode?
Everybody okay with all those?
I got error with the last column.
So now we're going to switch our calculator into radian mode because we have to find the radians, right?
No, you know that too.
Okay, I need to give our lesson.
No pain, no glory. Hater. How that's stupid.
That's almost like generic.
Put the radian.
So now we got to set it in radians. How do I know that B, for example, is a radian measure?
No degree sign.
No degree sign, right there. That's the reason. There's one way I know it's a radian measure. There's no degree. Okay? Sometimes there's a pi, sometimes there's a not. Totally not important. What matters is the degree mark. If you do not have a degree mark, you are a radian. So now I'm going to mode, and I'm going to highlight radian.
Wait, I had a question.
Okay, go to mode and highlight
I already
radian.
did.
Okay? As long as it's highlighted, you're good, okay? Now, we're going to type cosine pi over 9. Do I have a cosine button?
Yeah.
So cosine. Now use your pi button. We are in radians, so we got to use our pi button.
Oh, that's right.
So second pi, pi is right under the clear,
That was my question.
right?
I didn't know what pi was.
It's above, it's on my caret key, my little arrow power key. So second pi divided by 9. Did you get, it's actually going to be 0.940.
Yeah.
0.940 for problem B.
Miss Ford, are we always rounding in the thousands?
No, I just am, because there aren't any directions, I made that up. All right, now we've got D is cosecant 5 pi over 16.
So you be 1 divided by sine.
Exactly.
Cotangent.
It doesn't make any difference whether you're in degrees or radians. To get a cosecant, you have to do 1 divided by sine. So I know that looks kind of scary, but you're just typing it in. So it doesn't really matter what it looks like. Type in 1 divided by sine, and then 5 pi divided by 16. So 1 divided by sine, 5 pi divided by 16. And you do not need to add any extra parentheses. The only parentheses necessary come up for you. And did you get 1.203? So you're just typing that in just like that. The only parentheses necessary are right here, and they come in automatically. You don't need to worry about it. They're there. All right, next, okay, now we've got secant 18 pi over 23. Oh, the Zoom timed out because nobody was there. Hope he didn't try to get in. He did, he was really late. Okay, so what am I going to type?
1 divided by sin.
1 divided by what? Cosine.
Or cosine.
Yeah, it's got to be 1 divided by cosine. 18 pi over 23. So physically type 1 divided by cosine, 18 pi divided by 23. Negative 1.289.
9 0, right? Wouldn't it be 9 0 instead of 8 9?
After is a 1. Would a 1 round that up?
No, I'm saying, but with the 9 round up to 8.
Okay, I need 3 decimal places. So this is the one that's determining the rounding. Right? And one more. Cosecant 2. Now notice there's no pi, but that doesn't matter. There's no degree mark. That means it's a radian. So I'm going to type 1 divided by sine 2. 1 divided by sine 2. And I got, now that one is going to round. It's going to become 1, well look, what is that going to become? That's a tricky one. 1.0997. So I'm rounding here, right? So that 99 is going to have to be rounded up to 100. So my answer is actually going to be 1.100. That 99 is going to have to go up to 100. Was it positive? Yeah. Okay, so are we okay typing in on our calculator? What do we have to pay attention to?
The mode.
The mode. The degrees or radians. You got to pay attention to that. Because even if you type it in right, if you're in the wrong mode, you'll get the wrong answer. So make sure you are paying attention. All right, we're going to come back to the calculator if we have time. But first, we're going to do a little bit more no calculator. And this is like a big puzzle. We're going to figure something out here. And I think you're going to be able to do it pretty easily. All right? So here's what I'm going to do. I'm going to tell you that there's an angle out there that has a cosine of 1/2. That's what this problem says. It says there's an angle, and his cosine is 1/2. So I'm going to draw that same picture that I drew lots earlier, right there, just like that. And I have no idea what this angle is, so I'm going to call it theta. But its cosine is 1/2. What does that mean about this triangle if the cosine is 1/2? David? Exactly. So katoa. Does that make sense to everybody?
No.
Cosine is adjacent over hypotenuse. This is the adjacent side, and that's the hypotenuse. Yeah. Now, Look at your special triangles there, guys.
30, 60, 90.
That's a 30, 60, 90 triangle. Wouldn't this side be root 3?
Yes, sir.
And if that's root 3, then this angle has to be 60 degrees because that's the one that's across from the root 3.
That's the answer.
So how big is theta? Theta is 60 degrees. Very, very good. Let's try the next one. It says, oh, this one's a little harder. It says the sine is root 2 over 2. This one's a little harder.
Wouldn't it just be 45?
How do you know that?
Because the radical.
Okay, because you got a root 2 in it?
Yeah.
Yes, and it is 45, exactly. Let me show you why it's 45. But Kennedy's exactly right. She says, wait a minute, if there's a root 2 involved, that's got to be a 45 degrees. Now, technically, this is opposite over hypotenuse, right? And I know what you're thinking. This is a hard problem. You're thinking, Mrs. Ford, that does not look like the 45, 45, 90 that's on my paper. And you're right. If I did the Pythagorean Theorem on this to find that missing side, look what happens. X squared plus root 2 squared equals 2 squared. Just a squared plus b squared equals c squared. That missing side turns out to be the square root of 2.
How you doing?
Notice these two are the same. When those two sides are the same, it's an isosceles right triangle, which means it's 45, 45, 90. This fraction is the same as this. Remember, if we multiply to rationalize that, don't we get root 2 over 2? So there is the original fraction, and those are the right numbers. 1, root 2, those are the right numbers for your picture. I love Kennedy's idea though. She said, Mrs. Ford, this has to be a special triangle. There's only one special triangle that has a root 2 in it, and it's 45. So theta is 45 degrees. So if you don't understand anything that I just did with all of that stuff, okay, do you see a root 2? The only triangle that's got a root 2 is 45, right? So that's what we're going with. I could have just said that, but my job as a math teacher is to make everything as complicated as I possibly can. So I'm trying very hard to do that. All right, C. Here we go. C says we have a cosecant that is 2. Now, all of the trig functions, all 6 of them, sine, cosine, tangent, cosecant, secant, cotangent, are fractions. So I'm going to think of this as 2 over 1.
How are you?
Now, I have to draw a picture and figure out what angle is right here. And the cosecant is 2 over 1. Now, cosecant is the reciprocal of sine, so it must be hypotenuse over opposite.
So hypotenuse 2.
So hypotenuse is 2 and opposite is 1.
So it's 6.
So the other side is root 3.
60.
No, it's across from the 1. Which one's across from the 1? 30. That's a 30. So this time our angle is 30 because we want the angle across from the 1 this time. And we put the 1 there because that's the opposite side from the angle. And we needed hypotenuse over opposite. So the answer is 30. One more of those. These are probably the hardest ones, I think, in the
What
whole
class is
deal.
C.
So we gotta figure out what angle has a tangent of 1. So again, I'm gonna think of that as a fraction, 1/1. So when I draw my triangle, there's my angle I have to figure out.
Two, chapter 2.
What's tangent? Opposite over adjacent. So opposite over adjacent is 1/1. Oh, you should recognize that. This is √2, and that angle is 45. So theta is 45 degrees. If we're not using a calculator, every answer you get is going to be 45 or 30 or 60, right? Those are the only special ones you have at this point, anyway. Okay. Oh wait, there's more. I thought we were done. There's more. Okay, so secant 2/√3. Come on, guys, stay with me. We don't get to have this chance for many, many days, so hang in there.
Thought it would never come.
I just rationalized it. Remember, we're not supposed to have a radical in the denominator, so that really isn't a good way to read the answer, but I left it that way on purpose because it's going to be easier to draw. So I'm going to have one side is 2 and one side is √3. Okay? Now, secant. That is the reciprocal of the cosine.
So hypotenuse is 2.
So it's hypotenuse over adjacent. So hypotenuse is 2, adjacent is √3. That automatically makes the other side
So it's
1.
30.
And the angle across from 1 is 30. So the answer is 30 degrees. And then finally, cotangent is, I'm going to write it as √3/1. They are all fractions. When you were typing them in on your calculator, you got decimals, but can't you change decimals into fractions? Yeah, they're always fractions. So, what's cotangent? The reciprocal of tangent?
Opposite.
So it'll be, it's the reciprocal now, so it'll be adjacent over opposite, right? Cotangent, adjacent over opposite. So the adjacent side is √3 and the opposite side is 1.
Still 30.
So it's 30 again. That's another 30-degree angle. But I mean, they're all going to be 30, 60, or 45. So it doesn't matter that we keep getting 30.
Keep the 30 on the end. Definitely 30.
Okay? All right, now we're getting ready to actually do some real-life problems, so we got to practice one more skill before we're ready to do that. So we'll need our calculators. And in part 6, we have a triangle that looks like this. Pay attention. In part 6, we have a triangle that looks like this, and our job is to find x. Now notice, this is not one of your special angles. That's how I know I have to, it says to use a calculator, but I have to. I don't have a choice. So I want you to look at that angle right there. Never use the 90, always use the other angle they give you. So I'm looking at this 28. Which side would the 10 be? Opposite, adjacent, or hypotenuse? Opposite. So this is my opposite side. What about the oh, I just gave it away. The x is the hypotenuse, right?
Yeah.
Okay. Now, you're going to write an equation for all of these problems. you're gonna write an equation, and you're gonna use either sine, cosine, or tangent. And to decide which you're gonna use, you're gonna look at the sides that are involved in the problem. This side is not involved. The only sides that are involved are the opposite and the hypotenuse. So if opposite and hypotenuse are involved, which function will I use? Sine, cosine, or tangent? Sine. So you write sine angle. Drill it in your head. The angle is hooked to the sine, or the tangent, or the cosine. It's sine angle, cosine angle, tangent angle. And then that will equal opposite over hypotenuse, which is 10 over x. Sine equals opposite over hypotenuse. So that's my equation. Now to solve it, I'll do what I regularly do. I'll multiply by x. So I have x sine 28 equals 10. Farrell, this is really good stuff. Are you sick? Are you sick? Okay, please pay attention. So I have x sine 28 equals 10. Now I'm trying to figure out what x is, so I'll divide both sides by 28. And then I'll go to my calculator, and I will divide 10 by sine 28. But wait, did you go to mode and change back into degrees? No. This is a degree problem. See how easy it is to get tracked? You've got to remember to check your mode. So I go to mode, highlight degrees.
21. 21.
And then type 10 divided by sine 28. Did you get, does it tell me how to round? Did you get 21.30? When you did 10 divided by sine 28. So the hypotenuse of this triangle is 21.30.
Wouldn't these one always be degrees or
Huh?
Wouldn't these always be degrees?
They don't have to be. Usually they are, because we're used to working in degrees more, but they'll be in radians in your calculus class.
No.
Okay.
The
All right,
next
let's
one's
look at B.
cosine.
Okay, listen, you guys, listen. Jaden is actually paying attention, and he has already figured out that question B is going to be a cosine problem. Now, I need all of you to recognize that's going to be a cosine problem, because with regard to the angle, this is the adjacent, and this, of course, is the hypotenuse. And the function that uses adjacent and hypotenuse is cosine. So cosine 13 equals 4 over x. Cosine angle equals adjacent over hypotenuse. So now what do? It's just like the last one. How do I solve that? Multiply by x, thank you. So x cosine 13 equals 4. Just multiply the x over to here. And then your job is to say x equals. So we're going to have to divide by cosine 13. So we'll have 4 divided by cosine 13. Well, we have all those buttons, so we'll just press them. 4 divided by cosine 13. And did you get 4.105 for your hypotenuse? same right triangle. But now the angle's up here, doesn't matter. What function am I going to use this time? Tan. Tan. Why am I using tan? Because with regard to the angle, this is opposite and this is adjacent. See how the hypotenuse isn't involved? So I'm going to use tangent. So what will my equation be? I'm going to use tangent. What will my equation be? Tan 52. Always tan angle. Once you decide you're doing tangent, do tan angle and then equals what? Opposite over adjacent, which will be x over 5. How do I solve that? Times 5, yeah, that's an easy one. So 5 tan 52 equals x. I'm just timesing both sides by 5. So 5 tan 52 equals x. So 5, oops, turn it on. 5 tan 52. And this is another weird rounding. I got 6.400 because the 399 gets rounded up to 400. Is that not right? I thought some people were giving me kind of a weird look. Did you get 6.3997? Yeah, that's going to round to 400.
On it.
You're on it. All right, try D on your own. See how far you can get with D. See if you can figure out which function and write the equation. This is D. Okay. Anybody come up with an equation for that one?
Cosine 17 equals x over 10.
That sounds beautiful to me. Do you agree with that, Farrell? Is that what you said? Yep. Why did we pick cosine?
Because the x is adjacent to 10 to the 5.
Yep, perfect. Have you solved that?
Yep.
You multiplied by 10 and then typed it in on your calculator. 10 cosine 17. Did you get 9.563?
Yeah.
Perfect.
You said what?
9.563.
We got time for one more.
Can you come up with an equation for this one?
Yeah.
Sine 63 equals 5 over x.
Sine?
Yeah.
Yeah.
Close.
I think it's cosine, folks. With regard to this
Yeah.
angle,
Adjacent hypotenuse.
isn't this adjacent
Yep.
and this hypotenuse? Wouldn't this be the opposite side down here?
Yeah.
And I don't know anything about it, so I can't use sine because I don't know anything about the opposite side. So I'm going to have to use cosine again. So it'll be cosine 63 equals what? 5 over x. Adjacent over hypotenuse. Perfect. When you write your equation, you pick sine, cosine, or tangent. And then you say cosine angle, or sine angle, or tan angle. I know you think I'm being crazy because I keep saying that, but I'll have kids put cosine 5. It's cosine angle. And then that equals adjacent over hypotenuse. All right, how do I solve it?
Multiply by x.
Multiply by x. So I have x cosine 63 equal to 5. Multiply both sides by x. And then divide by cosine 63. Then I go to my calculator and I just type in 5 divided by cosine 63, 11.013. Does that look about right? What we have next, which we'll do on Monday, we'll do these word problems. So I can tell you right now, your homework 4.2 will be due on Wednesday next week, okay? So, because we'll finish this on Monday, we'll do these, sit down, we aren't finished, sit down. We'll do these word problems on Monday, which means our homework will be due on Wednesday for 4.2. Okay? Now, wait. I know that your brains are totally fried. You can go ahead and pack up and put your stuff away, but I want your attention because we're going to do one more problem. But you don't need to write it down. I just want you to help me do one more problem. Okay? But you can go ahead and pack up. Please, no phones. I need you paying somewhat attention here. These are some of the most critical problems for your continued future study of math. So I want to make sure that we haven't lost how to do them. We did some earlier. We just want to make sure we can do it. What if I said to you, let's find the tangent of pi over 3. By the way, the top sheet of that packet I gave you has more like this to practice if you want to. So what do I do? Change it to 60. Tangent 60. And for those of you that haven't been paying attention, we got 60 because we know pi radians is 180. Right? Now, we're not using a calculator for this. I know you could type that in and get 1.7 whatever. That's not what we're doing. We're doing this by hand. So we're going to draw our triangle, and we're going to put the 60 right there. We draw this triangle a lot, and the angle always goes at the origin. Okay, when you put it on the axis like that. Now, what do I know about the sides of this triangle? Because that's a 60 and that's a 90. I know this one's 30, right? So this side has to be 1. This side is √3. And this side is 2. And now I can do tangent. Because I know tangent, I erased it, but TOA, tangent is opposite over adjacent. Remember, this is our angle. So this is opposite and this is adjacent. So the answer is √3 over 1 or just plain old √3. Okay, those are important. Don't lose or don't forget how to do those. All right, the desks are clear. Coming around this way. Whose turn is it to hand out? Clara?
There's a dot.
Alex?
I submitted a picture. Definitely didn't look at both.
The wheel fell
I'm
off.
fried. It's kind of fried.
Yes, we were waiting on you.
Cool, bro. So hard about it.
Did you get to put that piece on?
I did.
Of course you didn't, because it would not be